Okay, so now this is a video for example 2. So as again, diploma students, you actually do need to know how to use the enthalpy cycle. So let's do this question. In some ways, chemistry is better by kind of doing these practice questions. So two forms of carbon graphite. The graphite form is the lead that we use, lead pencil, diamond or diamond. So using the enthalpy of combustion of graphite and combustion of diamond, calculate the delta H of the conversion from graphite to diamonds. Okay, that's the equation that you kind of want to get to. So what you need to do in some ways is actually draw out or write out the equation of um, combustion for graphite, right? So I'm just going to write it here. So combustion for graphite is, this is the calf. O2 gives you CO2, right? So that's combustion of graphite. And this here is the road. Okay. It is the enthalpy is minus 394 kilojoules per mole. Okay. So that's the combustion for graphite. Now, combustion for diamond. So if you use this information, combustion for diamond. So it is still carbon, it is still oxygen, but it goes to carbon dioxide, right? So in this case, I'm gonna, in some ways, I'm gonna tilt this sideways, maybe. So in this case, you have. Let's not do it this way. Let's just do it this way. So it's slanted, okay? So I can still draw horizontally. Sorry about that, guys. So in this case, I have carbon for diamond plus O2. That gives me CO2, right? So that's what happens when you're burning. So when you combustion of diamond, as it says on the handout, it is minus 396 kilojoules. Minus 396 kilojoules per mole. So what you're trying to do is you're trying to calculate the delta H to go from here to here. From here to here. So what you need to do in this case is now, because in some ways, if you kind of going back to what we talked about before in class, you can't do this experiment itself, but you can probably do this in school. This is kind of expensive, but yeah, you can technically do it. So in this case, what you need to do is it's going indirectly back down here. So if you're going to go back this way, I'm going to use a different color to show the difference, right? So if that's the case, you're still going this way. So it's still minus 394, but you have to flip this equation, right? So you actually have to have this equation going from carbon dioxide to this form. Carbon dioxide to this form. So in this case, if it is reversing the reaction, the sign would also be changed. So this here will be delta H equals plus 396, right? Kilojoules per mole. Same unit as before, but I ran out of room. So in this case here, for this, the new delta H would be, the delta H here would essentially be minus 394 plus positive 396, which gives you 2 kilojoules per mole. 2 kilojoules per mole. Okay? So that's what happens. Now, you might wonder, it's like, hey, This is CS plus O2. Now it's CS plus O2. So what's the deal? So what's the deal with this oxygen? Now, if you kind of write on the side, if you write horizontally, you don't have to, I don't think, but it just helps you to kind of keep understand what's going on. So in some ways, you're like, oh, you're talking about this equation, right? Or this reaction, right? Because that's what you have here. Isn't aren't this not the same as this one? You just want graphite to diamond, right? You're right. It doesn't look like it, but if you think about it, hey, oxygen is like a it's just there. They're not doing anything. It's like oxygen as a reactant, oxygen as a carbon. So in this case, you actually can cancel this out, okay? So what you really have here is really just CS graphite to CS diamond. Okay? So, and this, as you can see here, it's really just plus, okay, sorry, equals 2 kilojoules per mole, plus 2 kilojoules per mole. So that's how you do question using the Enfos P cycle like this. Okay? I'm going to make another video to talk about example number 4. Okay?